Good evening, everyone. Today, we're going to be talking about computer vision in artificial intelligence. But before that, we'd like to introduce ourselves. First, I'm Sal Santos, together with Uriel Aragon, Zoe Candelaria, and Penny Lane Tolentino. Well, let's move on to the next slide, please. Okay, so what are the objectives of our presentation? Well, first, it is to explain the concepts and workings of computer vision. Like, what are the fundamental concepts of computer vision and how does it work? Is it applied? And how is it applied in today's time? Next, we have to explore the applications of computer vision in fields such as healthcare, security, and daily living. And lastly, discuss the benefits, challenges, and future directions that shape computer vision's continued development. Next slide, please. Okay, so you may ask, what is computer vision? Well, it is a branch of artificial intelligence that allows computers to interpret and understand visual information such as images and videos. It's like how humans see the landscape, people, or whatever it is, and interpret it into something else. So, but how? Well, it is by combining machine learning, image processing, and pattern recognition. Computer vision enables machines to analyze visual data and make decisions based on what they see. And so, where is it used? Well, in recent years, rapid advancements in deep learning have transformed computer vision into a powerful technology used in various fields, from detecting diseases in healthcare to enhancing surveillance in security systems and improving convenience in our daily life.
Now we're going to take a look at the practical applications of computer vision. In medical uses, computer vision can be used as a tool to find benign tumors or developing cancer stages that help diagnose and provide immediate treatment should they arise. And then next up, we have, in terms of surveillance, the Chinese government has mandated in small parts of China to use computer-based vision as a tool to measure civility and reward those who obey laws. Although the implication surrounding this use is hugely controversial, it remains to be an essential tool of mixed use of computer vision for future cases.
Now that we understand how computer vision works, I will discuss the process on how computer vision works. So first is the image input. A camera sensor, or uh, like how humans see in the real world. So for example, uh, uh, for example is the camera or a sensor that captures an image or video. The second process is pre-processing. This is when the computer cleans up the image and remove noise or blur to make out clearer. The third is feature extraction. The system looks for patterns like edges, colors, or shapes that help identify the objects. For the fourth is the object recognition. This is where AI compares what it sees with what it has learned before, such as identifying a cat, a car, or a person. And the last is decision or action. This is where computer decides what to do next. For example, is when unlocking a phone. Another example is a guide on a self-driving car. So in simple terms, computer vision helps machines see, understand, and act. Uh, just like the definition, computer vision is like mimicking what people do. And for the application, next slide, please. Um, Computer vision applications are widespread, enabling machines to see and interpret data. Below are some fields where it used, how they are used. and its benefits and disadvantages. First is the healthcare. Computer vision is very helpful in medical imaging, like analyzing X-rays and MRI scans. It helps doctors detect illness more accurately and quickly. For example, spotting early signs of cancer or fractures that the human eye might miss. It also prevents misidentification of patients by verifying medical data and records through images. However, computer vision isn't perfect. If the system or the device doesn't work properly, it can give inaccurate predictions which could affect diagnosis. But still, with the proper use, it's becoming one of the most promising tools in healthcare. Second is security. In security, computer vision helps authenticate employees using facial recognition. It also tracks movements in large areas like banks, airports, and retail stores to improve surveillance. For instance, many modern airports now use face recognition to verify passengers' identities, which speeds up check-ins and enhances security. And the good thing is that it improves identity verification and makes monitoring more efficient. But it also have a downside. It raises privacy concerns since some people might not feel comfortable being recorded or scanned at all time. There is also a risk of misidentification, especially in crowded or low light environments. Next slide. Third is in agriculture. In farming, computer vision helps monitor crops and livestock. For example, drones equipped with cameras can check the health of plants, detect pests, or monitor animal behavior. This allows farmers to detect problems early, which prevents crop losses and improving animal welfare. However, it can be expensive because of the drones, and its accuracy often depends on weather and environmental conditions. Still, this technology is helping farmers work smarter and not harder. And for the last application is our everyday life. We also experience computer vision in our daily lives. When you unlock your phone using facial recognition or or organize your photos by face or objects. That's computer vision at work. It also makes our life more convenient and our devices more secure. But again, it also raises privacy concerns since it relies on personal image data. So as we see, computer vision isn't just a fancy AI concept. It's something that affects healthcare, security, and agriculture. Uh, it uh, it somehow changes how we see the world and how technology sees us too.
For the future outlook of computer vision, there are three major trends shaping its development. So, for the first one, we have multimodal AI integration, combining vision with language and audio so systems can truly understand context. Second is edge and real-time processing, moving AI to devices for faster, private, and efficient performance in cars, drones, and wearables. The third one is explainable and ethical AI, making vision models more transparent and trustworthy to prevent bias and ensure fairness.
And so, in conclusion, computer vision enables machine to quote unquote see, understand, and act on visual data by analyzing the world through AI, machine learning, and image processing. Its applications span various fields such as healthcare, security, agriculture, and our everyday life, making tasks faster, safer, and more efficient. As computer vision continues to evolve through advancements in multimodal AI, edge computing, and ethical AI development, computer vision offers overall benefits like improve accuracy, safety, decision making, and however, it also raises concerns that are related to privacy, ethics, and reliability. Well, on the brighter side, we have to look forward to the future as technology points towards smarter and more ethical, as well as more integrated systems that enhance our ability to see and understand the world. And so this is See the Vision. I am Sal Santos along with Uriel Aragon, Zoe Candelaria, and Penny Lane Tolentino. Thank you for watching.